any questions over any of the assignments thus far?
Sir.
We did not. Yeah, so the others. End of the day of the test. So when we take the chapter 1 test, it'll be sometime probably after next week. So don't wait till the last minute to get them all done, but you do still have some time to get them done. I think we finished off on this one here. Yes. So we're going to look at this one here next. And again, what we started yesterday was applying these transformations to the functions. So for this first one here, we want to write a function h whose graph is a reflection in the x-axis of the graph of f. So be good to have a writing utensil. So h of x is equal to. So if we're talking about a reflection in the x-axis, we're looking at negative f of x. So this is the general form for our reflection in the x-axis. And for us here, f of x, we can go on to replace it with its function. So it's the absolute value of x minus 5 minus 4. So we put the negative in front of it. And now all we need to do next is to distribute the negative through the function. So apply it to the absolute value and apply it to the negative 4. So we multiply that negative by the absolute value. We're just going to get negative absolute value of x minus 5. And the negative times the negative 4 is going to make it plus 4. And that's it. Any questions over this one here? All right. We can go on and look at the next one. Now this time we don't want to have a reflection in the x-axis, but this time we want a reflection in the y-axis. So instead of looking at negative f of x, we're going to look at f of negative x. Because f of negative x is our reflection in the y-axis. Now, since we have f of negative x, we need to replace every x in the function with negative x. So we'll take our function, the absolute value of x minus 5 minus 4, and we'll get parentheses negative x minus 5 minus 4. Now, since there's nothing in front of our parentheses, with the negative x, we can just remove them, giving us negative x minus 5 inside the absolute values, and we still have the minus 4. And that's it for that there. Any other questions on these here with reflections across the x or y axis? Do we feel comfortable with the reflections across x and y? Okay. If we feel comfortable with that there, we'll look at these next two here. Horizontal and vertical stretch. Yes. Okay, there's probably another one over there. Yep. So for horizontal, we're looking at 1 over a, and we're going to input it into the function. inside the function. So for the graph, when we apply a horizontal stretch or shrink, we're looking at y equals f of a times x for horizontal stretch or shrink. And whatever value they give us, we have to flip it. So if they tell us that it's a horizontal, or the value of the stretch or shrink is 4, when we plug it in, it's actually 1 over that. Or if they give us as 1/2, then we have to flip it to 2. Because a horizontal stretch or shrink by a factor of 1 over a, where a is whatever the value is. So we're just flipping it. Now, when we talk about vertical stretch or shrink, we're looking at it in the general form of a times f of x. So we're just multiplying whatever that value is through it. We don't have to do anything with vertical stretch or shrink. So when we look at this first one here, let f of x equal the absolute value of x minus 3 minus 5. Write a function h, so h of x, whose graph is a vertical stretch of the graph of f by a factor of 2. So when we talk about vertical stretch or shrink, we're looking at a times f of x. When we talk about a vertical stretch or shrink, we're talking about a times f of x. Now, what is the value of the stretch or shrink that we're dealing with for this function here? It is 2. So 2 is going to go in place of a. And it doesn't really matter if it's a stretch or shrink. We're still going to be using the same general equation. If it's a shrink, we'll be putting a fraction or a number between 0 and 1 in place of a. If it's a stretch, we'll have a number greater than 1 that will go in place of a. Any questions on this so far? Well, since we didn't change, it's still just f of x. We can replace f of x with its function, which is going to be the absolute value of x minus 3 minus 5. And at this point here, we can multiply through by the 2, so the 2 will multiply by the absolute value and the negative 5. So we're not going to multiply the 2 into the absolute value, it's just going to go out front. So I have 2, absolute value of x minus 3, and 2 times negative 5 would be negative 10. Any questions on this here? Any question on anything we've done so far? So this here is almost similar to what we did for a reflection across the x-axis. Instead of applying a number, we applied a negative for it, and here we're applying a number. So now let's look at this one here. So we have the same function, but we want to write a function g of x, or g, whose graph is a horizontal shrink of the graph of f by a factor of 1/3. So for horizontal stretch or shrink, we're talking about f of a times x. Now for horizontal stretch or shrink, we have to flip the factor of a. And this time a is what? A is 1/3. So if I flip 1/3, what does it become? 3 over 1 or 3. Because whenever we talk about horizontal stretch or shrink, the factor that we plug in for a is 1 over whatever we have, or we're flipping it. So here it becomes 3. Any questions on this here? Yeah, I'll do it again with vertical, because normally I'd get away from these here, because horizontal, it's really just remembering this flip. So we don't do too many with horizontal, especially on the homework or test. But I want to show you at least one. We'll go back and do this vertical here in a second. Now, if we did this horizontal, at this point here, we're just going to plug 3x in for every place that there's in x. So we'd have absolute value of 3x minus 3 minus 5, which will actually just give us the absolute value of 3x minus 3 minus 5, and that would be it. Questions on this here? So that's if it was horizontal, and it says vertical, yes? Because I think they all say vertical. So I'm going to go on and erase this. So if we talked about this being vertical, we would say that g of x is equal to a times f of x. So if it's a vertical shrink. Well, our value of a in this case would be what? 1/3 times f of x. 1/3 times f of x. And since we didn't do anything to f of x, it's still just f of x, we can plug the function in, which will tell us that we have the absolute value of x minus 3 minus 5. And we're going to multiply each part of this function by 1/3. So we'll multiply the 1/3 by the absolute values and by the negative 5. And if we multiply by the absolute value, we're just going to get 1/3 times the absolute value of x minus 3 minus 5/3. And that's it. That's all we'd have to do for this here. Any questions on any of these here? Okay, that's fine. Any other questions? Are we good? I think this also says vertical, doesn't it? Let's do that. That. Vertical. So this time we want to see, write a function g of x whose graph is a vertical stretch of the graph of f of x by a factor of 5. So if we're looking at the general case for a vertical stretch, we're talking about a times f of x. And for this one here, the value of a is, well, we don't need f of x. We can go on and put it in, because we can go on and put the function in. We know what f of x is, yes? For this here, it's going to be the absolute value of x minus 1 plus 2. And again, just like the last one, we're going to distribute that 5 through. So we can multiply the 5 by the absolute value and by the 2. And we multiply by the absolute value, we're going to get 5 times the absolute value of x minus 1. And 5 times 2 is 10. And that's it. Any questions on this here? Are there any other questions on vertical shrinks? No? We go to vertical shrink. Let's look at this one here. I think this one should say horizontal. Or is it not showing up? Okay, by a factor of 2. So let's go on and scratch that out where it says vertical for this one, if y'all do have this one. Okay, so on the last one, number 6, where I think it looks like this one here, just write it, or actually let's just do this one here and mark out vertical. Let's do horizontal, because I'm going to have you do 2 horizontal on the homework. Because likely, for the most part, horizontal is not that bad. The only key to it is remembering to flip it. Because for this here, when we talk about a horizontal stretch or shrink, because this should be stretch actually, horizontal stretch by a factor of 1/3, we're talking about saying that g of x is equal to f of a times x, where a is taking whatever that factor is and flipping it. So a in our case isn't going to be 1/3, it's actually going to be what? 3. Yes, because it's going to be the opposite because horizontal shrink says that it's increasing slower along the x-axis. So that means it's going to be going up this way. And horizontal stretch means it's going faster along the x-axis, so it's actually going longer. Because a horizontal shrink is similar to a vertical stretch. Similar, it's not the exact same thing. And a horizontal stretch is similar, not the exact same thing as a vertical shrink. Does that kind of make sense? Now, at this point here, we're going to plug the 3x in for x. Just telling us that we have the absolute value of 3x minus 3. And that's it here. Any questions on any of this here? We ready for the next part? So the last thing that we have, because I feel like, yep, we're on to the last few pages, is this here. And we're going to be applying multiple translations to each of these functions. And the way that we're doing this is we're going to do it one at a time. So we want to let the graph of g be a vertical shrink by a factor of 0.25, followed by a translation at 3 units up of the graph f of x is equal to x. So we want to write a rule for g. So our finished function, we'll be calling it g of x. So for the first one, I'm going to say h of x is equal to. Because the first thing we're going to do is this vertical shrink by a factor of 0.25. So when we talk about vertical shrink or vertical stretch, we're talking about a times f of x, the function we're starting with. Now in our case here, a, our vertical shrink is what? 0.25. So what we can say is that we can say 0.25 is a, and our function itself, f of x, is what? Just x. So now we just need to multiply those two together, yes? Which will tell us that h of x is equal to 0.25 times x, which is just this here. Any questions on this so far? So we finished with this problem. Did we do everything it said? No, because what else do we need to do? Up. So now we're taking our new function h of x and moving it 3 units up to make g of x, our final one. So we're saying g of x is equal to, because for vertical translation, is going to be h of x plus k. Because we're saying h of x, because we're not talking about the original function f of x anymore. We're talking about the one in between. Now for us here, our value of k is going to be what? And it's going to be positive because it's moving up. Now what is h of x? Do we have any like terms that we need to combine? No? So it works out that this here is the final answer. So when we combine them, it's not any different than what we've been doing before. We just have to do multiple of them together, one after the other. And we're always going to go in the order in which they are listed. We're going to do that order. So any questions on this here? So we'll look at one more of these here, and then I will let y'all work on the homework anytime that we have left. Now this next one here, let the graph of G be a translation 6 units down, followed by a reflection in the x-axis of the graph of f of x equals the absolute value of x. Write a rule for G. So since we're finishing off with G, we can call the first one h of x. I'm just picking h of x mainly because that's what we've been using. We've been switching between h of x and g of x, so we can start there. Now, since we're talking about a translation of 6 units down first, we're saying that this is equal to, in the general form, f of x plus k, where k is our translation up or down. Okay. Well, the value of k in this case is, and it would be negative because we're going down. Now we can also plug in f of x, and f of x is going to be absolute value of x. Well, we didn't really need the parentheses around the absolute value because there's nothing in front of it. There's no signs we need to alter. So this is it here. So we did the first part. Now we need to have a reflection in the x-axis to get us to g of x. And a reflection in the x-axis is negative, and we'll say h of x because we're not talking about f of x, the original function, anymore. We're talking about the function after it's been translated 6 units down. So a negative, and we can plug in our function, which would be the absolute value of x minus 6. And if we distribute this negative through, we'll get negative absolute value of x, because the negative times the absolute value will just give us negative absolute value of x. And the negative times negative 6 will give us plus 6. And that there would be our final function. Any questions on any of this here? Okay, that's fine. And that's it. That's all we are doing for this here. So we are finished with 1.3.